Some people might ask, why would you want to put a diesel engine into a Reliant? More people might ask, why would you want to drive a Reliant at all? It might not be the most comfortable thing you've ever sat in. But if you're looking for a simple car with a chassis that you can maintain yourself with basic tools, you could do no better than this. Starting at the front of the car, we have a standard radius arm which is fitted with 12-inch wheels. The only difference here is that the forward strut has been replaced with a stronger spring unit. Anyone who's driven these cars will know that the forward suspension is quite soft, and an encounter with a pothole or a sleeping policeman will generally bottom out that suspension. So a stronger spring seemed a good move, considering that we're now carrying an engine which weighs 57 kilos as opposed to the original 850 petrol engine which weighed in at 37 kilos. This is the radiator, which is a stock radiator as fitted to Kubota stationary engines. It is almost twice the surface area of the original Reliant radiator. Behind it is a fan, which has been exchanged for a suck blade as opposed to a blow blade on the standing engines. Apart from that, this is a regular standard cooling system with takeoff for internal heating of the cabin. The forward engine mountings use the original chassis lugs, but this time the bobbin anti-vibration units have been increased in size to a 60mm diameter and a 40mm depth. This spreads the load more evenly and facilitates the positioning of the engine. Perhaps the most difficult item to source for this build was the manual transmission and bell housing. This needed to be sufficiently slim to sit within the confines of the Robin transmission tunnel and to facilitate the fitting of the Hardy splicer joint and drive shaft to the rear wheels. After some research, it transpired that there were no manual gearboxes ever fitted to the 722 engine. However, the 900cc version of the engine did have the fitment of a manual gearbox by an American manufacturer. This turned out to be the Cushman Turf Truckster, which was basically a three-wheeled mule designed to carry 1.5 tons and which was basically a farm utility vehicle or perhaps a landscaping lawn maintenance vehicle, and it was the only gearbox that we were able to source. did have some difficulty in fitting the bell housing of this gearbox onto the 722 engine. It transpired that the rear engine plate on the 900 version of the engine was rather different from that on the 700 version, and this required the fabrication of a unique adapter plate. This required the mating of the center of the 722 engine plate with the outer of the 900cc version of this engine. This was achieved with a water jetting high precision CNC cutter through a local engineering firm who did a terrific job. The next problem was the flywheel. The flywheel on the stationary engine, the 722, was much heavier. This being of a greater mass to facilitate a steady running speed, which did not vary, on a welder generator set. This weighed in at 19 kilograms. This was far too much for a fitment to a manual gearbox, and so we turned this down in a lathe from 19 kilograms to 13 kilograms, and this is the flywheel which is now fitted to this engine. There are quite a lot of things that are still undefined as to their correct suitability, but so far in trials it's working out quite well. And we'll give it a little go. Working along the chassis, the next modification was to the handbrake. This was not entirely necessary, but is a great improvement. What we have here is a transverse shaft mounted on 4 bearings, and this is operated by a lever on the driver's side of a Vauxhall Zafira car, which has rather more increments on the ratchet for the pull. The load is spread much more evenly, and this turns out to be a much more useful handbrake than the original setup, which, as anybody will know that's driven these, to be in the zone for tightness had to be within a single click. With this setup, you basically have got in the zone around 3 clicks, just much more secure on the rear wheels. And here is that front bench seat, quite comfortable. It's mounted on a 28mm copper tube frame with a sprung canvas base, and the whole thing folds down into a kind of a bed if you need a bit of a rest. Pretty good. Working along the chassis, the next improvement is to the rear suspension. Here the single leaf springs have been replaced by dual leaf springs, the upper being a standard arced leaf and below a flat bar. These are referred to as progressive springs, and which become stiffer the more load is put onto them. We think this will be useful because we like to be able to carry the maximum load on these vehicles, which is at 450 kilograms. Lastly, we have fitted this 33-litre plastic fuel tank to the rear of the vehicle. This being an improvement on the original pressed steel units, which anyone with an older version of these cars will know that they rust quite badly. 33 litres is somewhat more than the original 27 litre capacity. The original tank with the petrol engine would probably take you 380 miles. This, if we achieve our target of 80 miles per gallon with the diesel engine, should get us around 560 miles on this tank. Here's hoping.
In the way. That's in there. Right.
In fact, we managed to achieve 88 miles per gallon on a 1,000-mile round trip to Scarborough with an average motorway speed of around 58 miles an hour. Well pleased with that. I never promised you the earth. I don't know what's going on here. This is supposed to be a bush channel. The Bristol Low-Decker Intercontinental World Travels. Coming up.